Now it's time to talk about one of the most interesting features of Go language. It's called untyped constants or typeless constants. Let's get started. Let's take a look at this program. It's the same program from a previous lecture. If you remember, previously I had removed the types from the constant declarations, and I told you that that change should have changed something behind the scenes. I also told you that removing types from the constant declarations has a consequence. In this lecture, I'm gonna lift the curtain and we're gonna explore the actual mechanics behind it. Okay, let's take a look. As an example, look at the second constant here, pi. Look at its initial expression. In the expression, 3.14 is a float literal, right? And mean is an integer. It multiplies a float value with an integer value. So how does it work? Remember, you can't multiply a float 64 value with an int value. Go has a very strong type system. So how this expression works then? Let's find out. This works because when you declare a constant without a type, that constant becomes an untyped or a typeless constant. So min here is just an integer value. It doesn't have a type. And pi here is just a float value. It doesn't have a type either. So they don't have types. They are simply typeless. This is why it works. They live out of the strong type system of Go. That's why I can multiply these two constants because they don't have a type yet. When you use them in an expression that requires a type, then Go will assign a type to them. Until that moment, they will stay typeless. You'll see an example about that soon. By the way here, as you now know that this is a float literal, and it's typeless. It's just a float value, but it doesn't have a type until a type is needed. All the basic literals are also typeless. Integer, float, bool, and string, and so on, all are basic literals and they all are typeless. They all are typeless constant values. Also, this mean constant here is just like an integer literal. It has no type. It's just an integer value. It is typeless. Let's see more examples to make this clear. Now let's declare a typed constant named min with an int type and an initial value of 42. Now let's declare an int variable. Then let's assign the constant to the I variable. Let's print it. Is it gonna work? Okay, let's try. Of course it works. It's because, as you can see here, the min constant and the I variable have the same int type. Now let's make it more interesting. Now let's declare a float 64 variable. Then let's assign the min constant to the f variable. And lastly, let's print the f variable. Okay, what do you think about this? Is this gonna work? Okay, let's try. Oops, there is an error now. Go compiler says that you cannot do that. It doesn't work because min is an int here, whereas the f variable is a float 64. So they have different types and they can't be used together. The strong type system of Go is in full action here. It doesn't allow using different types together. As you saw, the solution is using an untyped constant instead. Let's try the same thing with an untyped constant by removing the type from the constant declaration like this. As you can see, I removed the type from the min constant now. So it's a typeless constant. It's like a chameleon. It can change its type depending on where it is needed. Let's run it again. Cool, now it works. It prints 42. And there isn't an error. It's because when I assign the min constant to the f variable here, the type of the min constant changes to a float 64 value automatically. If I was assigning it to an int variable instead, then it would take an int type. Let's assign the typeless numeric constant min to a few numeric variables to see this in action. As you'll see, it will change its type accordingly. For example, let's assign it to an integer variable like this. Here, the typeless min constant changes its type to an int value automatically. Now let's assign it to a float 64 variable. Now it becomes a float 64 value. Okay, let's assign it to a byte variable. And then it becomes a byte value. Okay, let's assign it to an int32 variable. Here it becomes an int32 value this time. And lastly, let's assign it to a rune variable. And it becomes a rune value. Alright, now let's print it, then let's run it. As you can see, it works perfectly. Since it changes its type automatically, it can be assigned to any numeric variable. Let's take a look at what happens behind the scenes. Here is the same constant and a byte variable. I just assigned the typeless mean constant to the byte variable again. When Go sees this assignment, it's gonna convert the typeless numeric constant to a byte type automatically, like this. So behind the scenes, Go converts the mean constant to a byte value first, and after that, Go assigns it to the b variable as a byte value. Alright, that's all for now. I hope you understand the differences between typed and untyped constants. They are powerful. Untyped constants are like chameleons. So see you in the next lecture. Thank you for watching.